I'm Jens Brockmeyer. I'm working at the University of Münster in the Institute of Food Chemistry, and I'm group leader of the food proteomics group, and we are mainly interested in analyzing food allergens, for instance, as well as developing methods for food authentication. In 2013, there was this huge horsemeat scandal where the official laboratories finally saw that really huge amounts of food contained undeclared amounts of horsemeat or completely consisted of horsemeat. And it's estimated that it was something around 50,000 tons of beef meat products that contained undeclared amounts of horsemeat, which is really an exceptional high amount of fraudulently blended meat and meat products. I was not directly involved in discovering this scandal. We at that moment we worked on developing a method for the detection of pork, which was not declared. This was referring to something called the halal food, as pork is really for Muslim communities and Jewish communities a problem when it's not declared, because they have ethical and religious concerns against the consumption of pork. And we then really saw that obviously horse is also a huge problem. And horse as well is not allowed for Jewish communities and for some Muslim communities as well. So we thought, we will introduce horse meat identification and detection in our method, actually. If you have several or different mammalian species, taking horse and pork and beef, for instance, what you always see is that you have specific differences in the genome, and you of course have then in the corresponding proteome, the complete set of proteomes, you will see differences. So the amino acid sequence for a given protein is in 90 up to 95% of cases completely identical, but there are some spots where the amino acid sequence differs. So we have so-called polymorphisms, exchange of amino acids, deletions of amino acids, insertions of amino acids. And this gives you the opportunity, when you characterize these parts of the protein, that you can then distinguish between whether this protein comes from pork, from horse, or from beef, for instance. So we finally ended up with identifying specific parts of protein, tryptic peptides. We digest the proteins using trypsin and have then short sequence stretches of the protein peptides. We can then efficiently analyze using mass spectrometry to get the sequence of this peptide and to tell whether it comes from pork or horse or beef. We have mainly worked with the first part was the identification of the peptides, and this is performed with high-resolution mass spectrometry. And we've used the Orbitrap from Thermo, as well as a so-called triple TOF instrument from AB Sykes, and they have both proven to do very well. So it's really high-resolution mass spec, and you can identify thousands of peptides in a single run. And the detection method, therefore you need to be really sensitive, and we have used the last generation Q-Trap MS instruments from AB Sykes, which is the AB Sykes 6500, because it's really, as far as I can see, at least one of the most sensitive instruments on the market.